This is part 7 of the Module 11 lecture. In this part, we're going to look at this problem. It's the same problem that we've been working with since the beginning of this module, where a student has an off-campus job and works 8 hours per week, and the student is thinking of working 16 hours per week, but he's worried as to how much this will affect his GPA. So we have the data that the Department of Institutional Research at UIW provided for 10 students. And as we did before, we adjusted or we fitted a simple regression model to that data. And now we want to see if the slope parameter in the population model is non-zero, and we want to do that at a significance level of 0.05. We also want to calculate the 95% confidence interval for B, for the slope parameter. All right, let's do this. All right, so we're going to follow for testing the hypothesis, our 5-step procedure as we've done all along. And now we need to look at the information that we have calculated. So in order to calculate this, the estimate for the intercept and the estimate for the slope, we will have calculated the average of the y values, the average of the x values, all these sum of squares, and of course this coefficient, as well as the standard deviation of the residuals. And we're going to use this as we progress with this example. All right, so step 1, the hypotheses are that the slope parameter is 0 versus the alternative hypothesis that the parameter is not 0. Because of the alternative hypothesis, we know that this is a two-tailed test and the significance level is 0.05. All right, what distribution to use? Well, if you remember, we talked about that we're assuming that the random errors for any hours worked per week are independent, normally distributed with mean 0 and constant population standard deviation, which is estimated with the standard deviation of the residuals. Therefore, we are justified to use the t-distribution with 8 degrees of freedom. All right, so now that we know what distribution to use, we proceed to calculate the test statistic. Now, under the assumption that the parameter is 0. So this is the expression for the test statistic. We have the values. I put the values that we know here. So we can just put them into the equation, and you see that the t observed is minus 2.6162. All right. In step 4, if you're asked to follow the critical value approach, then you will go to table 5 with alpha over 2, because this is a two-tailed test, and the degrees of freedom of 8. And then you will find the upper critical value. So you go up to the table, look at the row for 8 degrees of freedom, look at the column for 0.025 probability, and where they intersect, you find this value 2.306. And that's an upper critical value. And by symmetry, the lower critical value is minus 2.306. Remember, the t-distribution is symmetric, so that's why we can do this. Now, finding the critical values is not enough. You need to specify what the rejection regions are. So don't forget this. Always specify the rejection regions. So the rejection regions in this case is for any t-value less than 2.306 or any t-value larger than 2.306. So this is what you would do if you're asked to follow the critical value approach. If you are asked to find the p-value approach, then you go on table 5, look at the row for 8 degrees of freedom, and find between which values the t-observed is. So the t-observed in this case is minus 2.6162. And what we're going to do is use the positive value because of symmetry. So we find that value, look at the row of 8 degrees of freedom, and you find that t-observed, the positive value, is between 2.306 and 2.896. And this corresponds to the probabilities of 0.025 and 0.01. So once you see these two values, you look up at the top of the table and you will find these probabilities. Now, this is a two-tailed test. So we need to multiply these probabilities by 2. So we can say that the p-value is between 0.05 and 0.02. If you want to find the exact p-value, you can use this formula in Excel and you will find that is 0.0308. All right, so now this is step 4, either for the critical value approach or for the p-value approach. All right, so now by using the critical value approach, we see that the t observed is smaller than the lower critical value. That implies that the t observed is in the rejection region. Also, we found that the p-value is lower than 0.05 but higher than 0.02. So the p-value is smaller than the alpha of 0.05. So by either approach, you determine that the null hypothesis is rejected. That is, the slope is not 0. So the interpretation of this decision is that at a significance level of 0.05, we can say that the slope parameter is not equal to 0, indicating that the hours worked per week significantly affect the average GPA of students. All right, so that's the decision based on the hypothesis test. But we will also like to find out the confidence interval for this parameter. So to do that, again, we need to justify the use of the t-distribution. As we say, since the random variables for any value of x are independent and normally distributed with mean 0 and constant standard deviation, and that population standard deviation is estimated with the sample standard deviation of the residuals, then the t-distribution with 8 degrees of freedom can be used to construct the confidence interval. So here are the questions for the confidence interval, and then we find that the t alpha over 2 is 2.306 by going to table 5 with alpha divided by 2 and degrees of freedom of 8. So using this value, this critical value, or this t alpha over 2, and the sum squared of the xx, the b, the estimate of the slope, and the standard deviation of the residuals, then we use these equations, we put those numbers into the equation, and we find these limits for the 95% confidence interval limit of the slope parameter. So we can say that at a 95% confidence level, the slope parameter is between minus 0.0559 and minus 0.0035. That means that for all students, the GPA will decrease between 0.0559 and 0.0035 points for an increment of 1 hour worked per week. This is very important. This is how I would like you to interpret the confidence interval, not just simply say that the parameter is between these two values. Use the interpretation of the parameter itself and the confidence limits to interpret what that represents. So in theory, we could say that for all students, their GPA will decrease between this number and this number for each 1 hour that they increment their hours worked per week. All right, so this will be the end of this problem. But what I would like to show you is how you can do this in Excel. All right, to do this, you need to install this data analysis tool pack. And this is not, most of the time, is not automatically installed on Excel. So you can look at the instructions that I posted on Blackboard to see how you can do that. All right, let me go on to Excel. What I'm going to do in Excel is recorded on the slides. So all right, so if you have this tool pack installed, once you click on the data tab up here at the top, then you will see this data analysis option here. So click on that, and that opens this window. And so in here, we want to look at the regression option. So when you select this, Excel will use least squares to calculate the coefficients and give you the inference information about the slope parameter. So click on that. Remember, please open the data first. Once you open the data, then go to data, then go to data analysis. Once this window is open, select regression, click OK, and then it's asking you for the input Y range. So the Y variable is right here. So you, with the cursor blinking on that window, then you click here, drag it down until the very last row, then click on the next window for to enter the input of the X variable, or the range of the X values. So again, once the cursor is blinking here, click here, drag it down to the very last value. And because we selected the labels of the columns, when we did our selection, click on the labels. Also click where it says confidence level 95%, and notice that you can change it if you want to. In this problem, we're asking for a 95% confidence interval. That's what it is. And then leave the rest alone. So use the new worksheet for the output. All right. Once you've done that, click OK. And then this is the output that Excel produces. All right. I'm going to switch over to the slides. So in the slides, I'm showing all these steps. And here, what I've done is documented here. So you can see it here, or you can see it on the recording. But then here's what Excel gives you. So here's the R-squared that we want. The other R-squared values are not applicable in this particular case because we have simple regression. Also, this analysis of variance table performs a test, an F-test that is equivalent to the T-test. So here, the ANOVA, the analysis of variance table, does not give you any information that is useful because the information that we want is in this lower table. So here's the A value, the estimate of the intercept value. Here's the estimate of the slope value. This is things that we calculated earlier. Here's the standard error, which is for the slope estimate. Here's the t-statistic value, and here's the p-value for the null hypothesis that the population slope is 0, and here's the confidence interval for B. So make sure that you know where this information is, because in the exam it's likely that I will give you this output, and instead of having you calculate things, I'll ask you questions about this output. All right, so we'll stop here, and then we continue in the next recording.